And I just need to think in what order I make. So you have also here a big tutorial that describes everything, how to compile and so on. Basically, also the one thing that I forgot, so maybe you cannot do it with me now, is that you need to install some things and set up a little bit for E2. So I forgot that. So, but yes, I will show you what you could do and what we could see and so on. And then, yes. Now, I compiled everything here. That is good. So you have here the description. I will do it relatively fast to come to the main point. The idea now will be that we use this E2 interface between a near real-time rig and then the GNLB. It would also work with the GNLB DU, CUUP, CUCP, and all that stuff, but we'll keep it simple. GNLB, and what I will do now in the following, and just show you briefly, is how to run the near real-time rig, make the connection with the GNLB, and then deploy an X app. And there will be actually two examples of an X app. The first one will be to get some statistics out of the base station. And the second, so this would be this KPM ORAN service model that I described previously. I don't know when I did. I mentioned this, which is basically a standardized ORAN service model. So yes. And the other will be for the RAN control service model. So in the RAN control service model, you have everything that is related to RAN control. The one example that I will show you now is just where the XApp requests to be informed when new UEs arrive or depart, when they connect or release. So I compiled it already in the background. I just need to now make sure that I the first thing that we should always do, so I try to also make this, let's say, a little bit pedagogical, is to actually, I mean, and I say this because sometimes people, they come and they say, okay, my RAN together with FlexRig doesn't work, but then actually the problem is, for example, that the RAN in itself doesn't work. Okay, the overall problem with all of this, which you have also seen in F1 and E1, that everything gets extremely complex, and the more entities you add on top, the more complex the whole handling gets. So the first step is always to just verify that actually the RAN itself works. So, and for that, I will just deploy here. Let me see whether the thing that I want to see works. Yes, it works. So you already see here that it talks about E2 setup requests. We'll come to this in one moment. Just connect the UE and it works fine. Okay, so let's assume now the RAN works. We can maybe make some traffic later. We will be able to see something in the XApp and so on. So, but I will stop. And what I wanted to say is now we see that there's this periodical output where the E2 agent that is now compiled into the RAN tries to connect. Maybe the one thing that I should actually point out here is that if you want to configure the E2 agent, and all of this is shown in the configuration file, then you see that there is here this E2 agent section now, which has been added, where we say that we want to talk to the near real-time rig at a specific IP address, in this case localhost, and that there's one directory with all the service model. So the reason why there is one directory with the service model is because it basically is based on some kind of plugin system where you could add or take out specific service models. But I don't want to go too much into the details. Basically, what you would do is you would compile FlexRig, also use this inside OAI. Then you would install these service models so that basically the near real-time rig and the RAN, they can use the same service models and so on. So, and now what I want to come at is that basically the first thing, I have a repository where basically I now have FlexRig deployed. I have already configured the RAN and run it and tested it works. So the only thing that remains to be done in a sense now is first to start the near real-time rig. So now we see that it has been initialized, that it's listening on a specific IP address, that it loaded a couple of service models. So the service models that we are interested into is KPM and RC. And now it's basically just waiting. And what we can do next is we can connect the GNLB. So we see here now that it connected, and there was some output and so on. It works fine. We don't see this periodical output, and in particular, if we now check here, we should also see this E2AP setup request and response. So now we have this additional interface. Let me actually limit this to only E2AP. So we see that here now there's this basically the same principle as all the time before. We have F1 setup request on F1. In E2, we have the setup request where now the genome B registers with the near real-time rig, which then answers with the E2 setup response. So now what we can already do is we could, for example, just connect the UE and do traffic, do all these kind of things that we were doing before. Okay. For example, send some traffic and the same things that we were doing before. All of this should work now. And now we have basically the near real-time rig deployed. We have the RAN running, and now the basic idea of this whole E2 thing is, of course, to deploy XApps. So if you still have some time afterwards, I have a general presentation to present the concept. So maybe for all those who know now, you have the near real-time rig, you have XApps on top that can consume services, for example, get statistics and also control the RAN. And the two basic things that I want to show you now is to first deploy one XApp that will just consume some statistics and show this. And in particular there, just see what is the throughput for a particular UE. And the second, as I said, to just see when a UE arrives and departs. So I need to copy this from here, there. So here, I mean, once more, this is the same as what we were doing before. In the tutorial, there's all the explanation how you have to start things, that you need to start the flex rig, then you need to start your GNode B and or maybe also CUDU and so on. You connect the UE, all the same things. Then there's some documentation on how to decode actually the E2IP, because I believe by default is not shown. Then you have here the E2 setup request and response, as it's mentioned here. And then finally, we can start test traffic. And now the one thing that I want to show you is the example for some monitoring using this KPM service model. So I just put this here for the moment. So we see that here there was some response or some interaction between the XApp and the near real-time rig here in the middle. And now the XApp gets actually the throughput. And the basic thing that I want to get at now, if I, for example, make like, let's say 5 megabits in downlink, then we still have the whole thing running. The overall user plane is the same thing as what we were doing before, but this time, okay, now the XApp stops after some time, so I need to start this once more. Basically here it now gets the throughput, but we send traffic and we see that the downlink DLB throughput is exactly this, well, 5,100 kilobit per second, because it actually measures this at the MAC layer and not as a higher layer. So here we have the application layer, and there it's somewhat a lower layer, but overall we see that the statistics that we get out of the RAN is what we also actually see in the RAN. Okay, so that's the first thing. The second thing that I want to briefly come at is this RAN control monitoring, which is basically kind of the same thing, but this time this XApp will just register to be informed when a UE leaves and when a UE comes. So basically I could, for example, just stop the UE, and then we see here that the RC of a particular UE with this ID changed to, and it went to RC idle, and so we know at the XApp that one UE left. If we then now connect, okay, well, no, the XApp stopped exactly in the wrong moment. That's not cool. We can start this once more, and we will now see that here one UE connected. So the RC state changed to the new state RC connected, meaning that basically one UE arrived and it made an RC connection. Okay. Other questions here? So this was a lot of information. I hope I didn't overwhelm you too much. The basic thing that we saw is really same GNode B and UE as before, the RAN, but this time only we have the rig running on top. The RAN registers with the rig, and on top we deploy this XApp, and this can request services, and the two things that we have seen is some monitoring for statistics, and the other was to be informed when the UE arrived and left. Sorry. Yes, so actually we saw this here a little bit. So of course, now I went, as I said, maybe a little bit fast, but you see here that it also has the PDCP volume, then some delay, then the throughput at the MAC layer, and also the total number of PRBs that were used. Actually, well, basically, for example, if you now send the traffic, we also see that here the number of PRBs that are being used in a specific interval is much higher than when there is no traffic. So if I stop this against here, then we see that goes down. Okay, the accept remains only active for 10 seconds. That's a bit unfortunate. Basically, we see 7,000 per interval. If I stop, it goes down. So the current number of statistics are exactly 7 numbers. So PDCP, uplink, downlink, RLC, latency, number of PRBs and uplink and downlink. 7. So to answer the question, yes, you can have more measurements. Actually, what they reference in this ORAN KPM service model is what is specified in 3GPP, and that is huge. So, and then you can, I mean, one of the things that are not implemented, but to give you an idea, you can, for example, also get the number of active PDU sessions, the number of active users, various latencies. I don't know if there's interest, I can show you there's one document, one huge PDF where you can read 300 pages of what you might get out of a base station. So, but by the way, since you already say this or mention this, it's not only, I mean, basically we have two things. We have these ORAN service models, but FlexRig also provides a couple of other service models with custom data format in there. Those are actually a bit more fine-grained. So for example, in this max stats, you also get the number of, I mean, the transport block size and these kind of things. And many of the things are also in 3GPP, but not always in the same format, or maybe not what you want, and so on. Yes. Well, it depends a little bit on the values. So I know that in the 3GPP model, for example, the throughput and so on that we see is OUE. But there are other things, for example, the MCS that is used. This is more like an aggregate across all UEs, and basically the dimension is not per UE. The dimension is, I think, number of layers. Well, the MCS itself, because it's more like a histogram, and the third thing that I forgot now. So, and then basically they have like a 3-dimensional histogram that just gives frequencies, something like this, you know. So, I mean, there's, for example, for the MCS, so basically distribution of the channel quality that is used for the UEs, this is kind of more like a distribution across all the UEs. And I think that's also intentional, because for a single UE, that might not be that interesting if you have a real network. Because, I mean, of course, for research and so on, it's interesting to see this, but if you have like a big deployment, you want to know what is the channel quality on average across all the UEs. You don't really care for like my phone. I mean, the operator, you will say, okay, Robert's phone. So, do we still have a bit of time, Albert, or what is now the... So, I mean, you got a brief overview here. This is something that you can try to do yourself. I guess we also have some time, so if you want to try, there's something that we could get at now. If there's interest, I just wanted to go over this. There's also actually a couple of slides that explain a little bit more the E2 interface and what is the thing with XApp and so on. So it depends a little bit on your interest, what you want to see. So I can also explain a little bit more. So we either might do some hands-on now if we still have some time, or do some presentation, or yeah, what's the plan? Well, maybe it would make sense to make this kind of on an individual level, like per table. I go around, and if people want to discuss, then we can discuss. And otherwise, if others want to deploy, for example, FlexRig, then they could try that. Would that make sense? And the others, they do the deployment. I mean, okay. I just want to also point out, I mean, we can do this if there's also some interest on the table. What I can, for example, present is, well, some of the terminology and so on. So this is basically actually one thing that explains a little bit what E2 is about and so on. So maybe I can go over that because this is actually relatively important to get some understanding. And then we can discuss how this might be used. And yes. Okay. Then I suggest we take this white table over there. There are only some people, and maybe we can discuss over there for E2, and the others they could try to deploy or start with the run as there's interest. Okay, so I can already start. So what we had now was a super brief overview of what E2 is and so on, and in particular the implementation. But I would totally understand if you now tell me that it was too fast and doesn't, I mean, not maybe that explaining that much. So I see this, and basically what I would like to do in the following is to explain a little bit again this, what is the E2 terminology and so on, and how it works, so that so that you have an idea of how things work, and then maybe you can apply this, and in particular we then look again FlexRig, it actually make a bit more sense, I think, I hope. So we will talk a little bit about the general ORAN architecture, ORAN E2 terminology. Then there's also some things about FlexRig. I think that's then much better, but understand. So this figure you might have already seen, right? So this is the general ORAN architecture. Just for those who don't know, basically what you see here is that you have, I cannot have my mouse, it's there. So you see here that you have the CUCP, the CUUP, the DU, the ORU, and then some infrastructure and different things. So basically here already we see the G node B, as I also had this at the end in the presentation with CUUP, CUCP, E1, and then the F1, and then actually you have the open frontal interface, so this is 7.2 split. So the 7.2, I also showed this to some yesterday evening. 7.2 basically is a split where you buy a box, which is a radio, and this is a standardized interface then to the DU. So all this, what you see here at the bottom, this is the G node B, and now each of those elements, they talk via this E2 interface to the near real-time rig. Okay, so the near real-time rig, the idea is that it controls and also optimizes run function, at least that's the idea, by either just taking out statistics for performance metrics and then also like controlling the run in some sense, or optimizing and so on. So there are various things. We also actually have one video how this might be used in like kind of a fancy, I mean, there's basically a game, and then we control and measure certain things, and we switch things in the run, and then it works better in some sense. Okay. Very often, also when people talk about this in the industry, it's more like along the lines of, okay, we optimize, and the network now is 10% more efficient, or can transport more traffic, and so on. So there's also one aspect of all of this, which is the E node B, so the 4G stuff, but we just leave this out. And then what they overall have in this architecture also is the infrastructure. So some hardware on which everything runs. There is also some management framework here to manage this infrastructure. And one of the overarching thing is the service management and orchestration, which has this O1 interface on top. So E2 is more for control, O1 is more for management and starting these entities. And for example, inside of the service management orchestration, you also have the non-real-time rig. So the near real-time rig is almost near real-time, and the non-real-time is not real-time. And to give you also one idea what this is about, basically you have the near real-time rig that really optimizes the run, and the non-real-time rig would, for example, as one example, I'm not a big fan of that, but AI/ML, for example, doing some training, and then via this A1 interface give a policy to the near real-time rig how it should actually optimize the run. Okay, so for example, tell it, okay, for a specific user group, you need to optimize and do something, and maybe like this or that in the best way, and so on. Okay, so basically, so near real-time rig officially, this is something like it should respond within 10 milliseconds. That's why it's near real time, and the non-real time rig is then like 1 second or larger and has a general overview where the near real time rig might still be responsible for specific part. Okay. So now the one thing with the X app that we saw, we will also see this in a moment, but basically the X apps now are applications that are deployed, let's say, alongside the near real-time rig, but from a schema point of view, it would be here inside of this schema that there are X apps, and those they use then services that are given by the near real-time rig. So for example, getting statistics, controlling certain things such as mobility and so on. Okay. Is that question is clear?
Is there a way to get the channel state information via an X app?
Yes, so I mean that's what I was describing before. So for example, I mean there is the KPM service model. We will also discuss in a moment what is actually a service model because this didn't appear yet. But basically there is a 3GPP standard, and it says what are the statistics that you can get out. And one of those standards is this kind of histogram across MCS, of which you can then see what is the channel. There's also CQI, so it might also export the CQI value across all the UEs. So then the X app could also consume those services and see what UEs report in terms of the channel that they see. Okay. So in short, yes.
Sorry, what these rigs is only the real-time rig currently implemented in
so the near
interface. So the E2 interface implemented in OAI, right?
Yes.
And A1?
No.
Not this.
So basically, what is an OAI? So maybe also that's actually a good question in the sense. So all what you see here, the ODU, ORU, OCU, PCU, CP, this is this OpenAirInterface 5G, the big repository that we cloned. Okay, and the near real-time rig is this Flex rig repository that I used that we didn't really see, and we will also see later what near the Flex rig actually does. Here's a kind of a mapping somehow. This figure that I showed on the first day, basically Flex rig does everything that is near real-time rig, but there's also some agent library. So basically what the run repository does, it uses Flex rig as a submodule, for those who know, a Git submodule, and it uses Flex rig to act as the agent side. So basically the interface side that is on the run. So here to then communicate up. Does that answer the question? So basically FlexRig is used to implement the complete E2 interface, and in the run it makes the E2 agent, and then on top the FlexRig also provides a near real-time rig and also accepts everything is in one repository.
Question. Do we always have to disintegrate the components?
No, yeah, this is something that they write in ORAN. I mean, as we have seen, at least in the OpenAirInterface, you can just run this together. So that was what I did at the end, and everything is together. And I don't really know why ORAN always writes with E1 F1. I mean, the general idea of ORAN is to make the RAM more open, and then they say, I think this is open, intelligent, and I don't know, interoperable. And the whole idea is that you split the RAN and then have different vendors providing their functions. And yeah, ORAN overall is mostly operator driven. I guess one of the motivations is actually also to bring costs down, because then there's more competition. It's not just Nokia or Ericsson that sells the complete thing, okay? But also one of the criticisms of the whole thing also, I mean, I give you a little bit my perspective on this. I think it's nice, in particular also for research, it's quite interesting to see what you can do. But one thing that clearly happens with that is that the complexity goes up. We've seen this in the Wireshark with all these messages and so on. Of course, this would happen, but Nokia has much more control over its own base station and the things that happen inside. And if you now have CUCP one vendor, CUUP another one, DU a third vendor, then interoperability, I mean, they try to make it interoperable and so on, but of course there are a lot of edge cases that might not work and so on. In OAI, you don't need to deploy like this.
Oh, okay.
You can.
But you
There
don't
might be use cases, for example, what we also mentioned, if you want to have F1 handover, you need to have multiple DUs, one CU, then you need to have. But in general, if it's just like running one base station, they can deploy everything together, and then there's only one E2 that does all the three together. So now there is some terminology. Maybe the interesting thing is what we should look at is the thing here on the right. And this figure actually really comes from the spec. What we see, we have here in the middle this E2 interface. On the bottom, what is labeled as E2 node is the RAN. So from an E2 terminology, all these CU, CP, CU, UP, and so on is an E2 node. Okay, so that's also why you have multiple, because these three might form one G node B, and on the top you have the near real-time brick. And basically, what they also say in now in the specs with the E2 node, which might be the entire G node B, has an E2 agent, and it has a specific functionality that might be exposed. So, for example, one specific functionality might be performance metrics, or might be mobility handling, and so on. Okay, this is a specific functionality that are exposed. There are also other functions that are not necessarily exposed. And on the northbound, also in the near real-time rig, you have the E2 termination. So this is basically a service that provides the E2 interface and maybe some database, and then you have all these XApps. And what they now say with the red lines here is basically that these XApp, they consume specific functionality that is exposed. Okay, and the reason, I mean, this is like a conceptual overview that tells you everything and nothing. I mean, super generic in a sense. I think that is made because you don't know in advance which functionality will be exposed. So there might be one vendor that gives you maybe access to mobility control and another one not. And in order to somehow conceptualize, they came up with that. That's all. So, and then you see here, I mean, the E2 is the interface between the two. Then you have actually the E2 application protocol, which is just the signaling between the near real-time rig and the E2 node. So the most classical one, I mean, there are a couple of things. There's the E2 setup request and response. There's a so-called indication message, which is just a message that goes up. You have a control message that goes down. You can also have a subscription where the near real-time rig sends something to the RAN and subscribes to some information, but it doesn't really say what it is inside, because it's more like this conceptual view of subscribing to some functionality. And yes.
So if you, let's say, develop your own X app, how do you know which functions are exposed?
So that is, I don't know whether we can see this here. Let me see. Do I still have open Wireshark? No, I closed it. Basically, when you set the E2 setup request and response, I think actually that's
it responds with
the inside.
function.
It says this E2 node, whatever it is, provides these services. So I think there was a key. Yes, here you see there is the E2 setup request. This is I mean you have this already, okay, but this is the E2 setup request, and inside you see that it has a list of RAN functions. So the RAN function is now what I had before in this.
Okay.
You took. Let me know once you
I'm following with you.
Okay, what I wanted to say, so the RAN function is really here, this function that we had here. So this is called the RAN function, okay? And in this E2 setup request, it provides a list of RAN functions, and inside each RAN function, you have an ID and something. And for each RAN function, it now says what is the short name and what does it provide. So for example, here, this is KPM, and it says that this one provides DRB PDCP, RLC, UE throughput, and PRB. So it's likely that this is an entire G node B, because it can give you everything. If it was only a CU, it might only give you PDCP, because the rest is actually in the DU. Okay. So there you see there's still this ultra concept. It's just concept, and the E2 node says in the beginning, okay, I can give you this and this and this and that. And the XApp doesn't know in advance what it will get. And it might get only a part because it's only a CU. It might only get a part because it's a specific vendor. So you have all this.
So how do you write them your X apps in such a way if you're not always?
Yeah, but
It will only work if it's available.
Yeah.
Like, pretty much.
See, you didn't know beforehand basically what you have available.
No, I mean,
Yeah.
So, but I mean, I have to say that, I mean, it looks a little bit complicated in the beginning, but I think it, in a sense, makes sense because you truly don't know what the RAN can give you, huh? And how it is deployed. So it might be one CU and it gives you mobility services, and it might be just some cell somewhere that doesn't expose mobility services, and you don't know in advance what you will get and so on. So that's why you have this thing. So this
Interesting,
basically
you can
here,
have multiple vendors supplying you CUs and DUs, but they can choose what they want to expose and what not. So then even
they
if you,
just close the
yeah,
market.
yeah, then it's
Let's
useless.
hope that doesn't happen.
so, and then for example, maybe they, all the CUs, they have functionality for mobility control, but they don't always expose it as is shown in this figure
Yeah.
here. So you might have these other functions, okay? So now E2 node is a logical node, which is either CU, DU or something. Then you have the RAN functions, which is the functionality that is exposed. And so now these three things, E2SM, rig service, and accept. So now we discussed already, we don't know what the RAN function gives. And we also don't know in advance what might be the format that will come. So this is where you have this E2SM, the service model. And the service model describes the format or the things that the RAN function can give you.
The photographers, they are going to, they have to disappear in about 7 minutes. So I'm just wondering if we can, within the next 5 minutes,
Make a group photo?
do yes, sort of a group photo. We did the group photo,
Yes.
right? But more of a short closing ceremony, and then we continue after the closing.
We can?
Sound.
Yes,
We can.
I think so.
So
I mean, maybe then would be a good point to make actually a break, to digest a little bit, and then I will follow up with the service model and explain that.
Yeah.
So, and then
So is
yeah, I mean, what I want, then I want to get to this slide that explains a little bit how this exchange happens.
So can you write your own functions or expose your own?
Yeah, well,
functions?
that's the whole point. You can then give the service model, which is the format of what the run function actually provides you. And if you have some non-standard functionality, so a separate service model. And the accept might use this or not.
Yeah.
I mean, then you have an accept that is dedicated to a specific service model and so on.
So let's say we want to do beam steering and you need that information,
Yeah.
then I can go and write my own functions to
Yeah.
expose some of those angles.
Exactly.
Arrivals,
Then you need an associated service model that gives. But I mean, I can go. Then maybe let's do the group photo briefly. And so, I mean, we are almost at the end. We will finish this small session over there afterwards. But at this point, since we are basically at the end, I would like to thank you all for your participation in the name of the OpenAirInterface Software Alliance and from all end. And I would like to thank CSIR for organizing this nice event. It was a very nice venue here. You are welcomed. I thank you for the interest, and I hope that you will take the knowledge that you acquired home to use OpenAirInterface. Please don't hesitate to tell us if there are like problems or if you get stuck with something. So this project is growing and evolving and meant to be improved. And with that, I hope that not only you benefit from learning about OAI, but that maybe hopefully also OAI can benefit from you. Thank you. We talked about the E2 node, which is just something in the RAN that reports some things via this RAN functions. We talked about the near real-time rig, which has the determination, and it may be a database, and then there are X apps, and these X apps, they consume specific services, or specific, we shouldn't say services, RAN functions, as, I mean, and also in an end-to-end fashion, okay? And now the question is, how do we actually expose the RAN functionality? And so this is the role of the service models, or E2SM. And basically they describe what is exposed. So as you already have guessed before, basically you can either use standardized one or you write your own. So in FlexRate, you basically have two standardized one. One is the RAN control, the other is the KPM. So that's what we saw, which both implement a small, fairly small subset. But you can also have custom ones. So we saw that there is, for example, MAC and PDCP and so on, where you potentially also might get more information. And now, of course, you have the format in a sense, but it's still not clear what is the interaction. And the interaction is what's called a service. So this I will explain in a moment, and then I think probably it also makes some more click how this interacts. And overall, what the X app now does is it will ask the near real-time rig, for example, to get informed about statistics, or will it just send a control message. So this I will explain, and via then the rig, it can actually talk to the RAM. Okay. If there's no question, then we basically, well, I mean, here's just once more. So we have E2, and E2 actually uses SCTP. I think that's maybe a right thing. And then the E2 AP, though they make the overall communication, so setup, request, response. There are a couple of basic messages which we will see in a moment. So there is basically subscription to make a subscription in the RAN. There are indication messages. These are messages that are sent from the RAN to the near real-time rig or X app, and there are control messages that go from the top to the bottom. And from this, everything is built. And now the E2 AP message, via these basic messages, they encapsulate service models which actually implement the actual RAN function. And the overall reports that exist are report, control, insert, and policy. So, and I will now explain in a moment what is report and control. The basic thing is that, in my opinion, I mean, the standard, they actually specify all of them that in like a dedicated way, but I find it very easy to, I mean, understand report and control, and insert and policy kind of follows naturally from the other two. So yes, and you also see, by the way, in the figure, so you have an E2 packet in SCTP, which has E2 AP, and inside you have E2 SM, and there's also kind of a double encoding involved. So all of this is using ASN.1, okay? So similar also F1, and apparently this was done, I was told, intentionally, because all the vendors, they already have ASN.1 for the different F1 and GAP and so on. That's why they use this, and so on. So, and now we come to the services. So as I said, there are 4 services, and 2 are really relevant for basic understanding. There's a report which is on the left, and there is a control which is on the right, okay? And the other 2 are merely combinations. It's actually quite simple. So you always have the near real-time rig on the left side, you have the E2 node on the right side. Let's now assume that we, for example, did the E2 setup request and response in the beginning, and the overall control is now established, and the near real-time rig does this action on behalf of an XR. Okay, so then also the question, by the way, as a side note, between the near real-time rig and the XApp is yet another thing. There are also specifications and so on. Let's just assume that the near real-time rig now asks for information on behalf of the XApp, and then between the XApp and the near real-time rig, this will kind of find its way. So, and basically what happens, the report is to report information. So basically the near real-time rig does a so-called subscription procedure to the E2 node. And inside the subscription, it basically does 2 things. It defines or requests for a specific event trigger. Typically, for example, for reports, that might be that it sends things periodically, but not only, it might also be on demand on specific events. And what this event trigger can be is actually defined in the E2 setup request and the RAN function action definition. Okay, so also here, it not only subscribes, specifies what might be exposed, and also at which times and in which formats. And then the rig subscription says that the action is to report something, okay? So this is done, there is rig subscription request and the rig subscription response, something like this. And then the E2 node, at some point, it detects that the event trigger is true. I mean, basically that it needs to send something. So as I said, might be in the simplest case periodically. This was what we saw in KPM. And then the E2 node sends an indication message. This is the E2 AP message, and inside it has a report which has the format of a specific service model. So for example, KPM. So periodically, every second or 100 millisecond or whatsoever, it sends an indication message afterward, and inside it actually has the statistics that have been requested. So there's the action which says what it wants to receive. It specifies before how often, and then these indication messages, they come. Does it make sense? So, and the control is simple in the sense of that there is some kind of internal event or something. It concludes, no, it needs to do some control. It might, for example, even be based on the indication messages and so on that were there, or AML or whatever. Then also the near real-time rig somehow detects that this is the time now and performs some action, and then it sends the rig control request to the E2 node. And then it gets a little bit more complicated, but basically the E2 node can respond in two ways. It can either acknowledge and say it did it, or it can say, okay, it failed. Basically, so also simple. And then let me see whether I have now actually the other diagram. Basically, the policy and the insert, they are kind of combinations. Let me open the spec and then we can see there. I don't see it. Oops. Then we need to go via this here and then here and then ORAN. And the one thing, if you want to understand, by the way, I can recommend you just go to the ORAN website. There you click on specifications, then you get all these specifications, and there you find the E2 GAP, the general aspects and principles. And this basically describes the whole thing. So I also just basically, you see here, this is the control thing, copy paste it. And for a specification that's relatively digestible, I would say. That's easier than reading 3GPP layer 1, and so because it lays out the basic thing. So let's maybe go up. So this is the indication that we just saw for a report service, and they really describe what can happen. The second now is the insert. So basically there we have also first the subscription, then the E2 node detects that now there is a trigger. So I give you one concrete example. What might be insert, for example, there might be from the rig a subscription to decide whether it should do mobility, or it wants to maybe trigger mobility events instead of the run doing it automatically. At least that's my interpretation of things, okay? And now, for example, it could be that the event trigger is, for example, when there are measurement reports from a UE, or maybe measurement reports for specific quality. And then you see here now, instead of just reporting this, the E2 node is requested to suspend the associated procedure. So it should not trigger the mobility, start some wait timer. Okay, we can ignore this. And then it sends the rig indication with the insert service. So for example, it might send the measurement report. And now the rig can either perform an action or not. So if there's some timeout, then some things will happen, but let's maybe just concentrate on the good case. So for example, it now decides, well, actually, it would be better to hand over to right and not to the left for mobility load balancing and so on. And then it will just send the rig control request. The timer is cancelled that we started because we do something, and then it does the actual procedure and afterwards acknowledged. So now I said, like, there's a combination, because you see the insert is basically reports, and sometimes you, well, or in this case, you actually need to follow up, but it's basically a combination of report, or, report and control. So, by the way, you looked a little bit lost or confused. What?
No, I was just thinking, like, sometimes when I focus, I look somewhere else instead of looking.
Yeah, okay, it's okay. So I mean, basically, the way I imagine this, and I'm not 100% sure whether this is true, okay, but I picture such as I said, mobility, some load balancing or something. You want to the rig wants to decide instead of the CU, because it might have a more global picture of the overall network. And it knows like maybe the status or the load in specific base station, and then it subscribes for insert. It gets the measurement report, and then it says, no, it's better, instead of hand over to there, maybe hand over to somewhere else. So, and the final thing, so then we discussed, so the control, no, this is still insert. This is control. Why do they have? Well, this is still insert. I don't know. This is now the control that we just set. It just said control. And the final thing is policy. And this is also relatively simple. You just have the subscription, and now the action is the policy. And it might, and then the E2 node just should act as the policy has said. For example, handover always there and not there. Or drop all requests from UEs that request slice X. something like that. So, and these are the services that they say, and then you also see they, I mean, now going back to this kind of conceptual thing, they have basically here the basic procedures. This is subscription, indication, control. You have 4 services, can be a report, insert, control, policy, and then there's something that is happening. So, and inside you have the service model. So now FlexRig. So FlexRig is the ORAN compliant E2 agent of OpenAirInterface. So it implements now the agent side and the rig side.
I'm assuming there are other rigs as well.
Yeah.
Is ORAN or the specific architecture also compliant with other rigs that you can operate on this?
So I mean, there are other rigs, many even I would say. I mean, probably, I mean, at least in open source, more rigs than runs. And I mean, FlexRig is compliant to other rigs. So maybe if you, do I have this slide here? This was in the initial presentation that I gave on Tuesday. I will just bring this up once more.
What's the advantage of FlexRig?
Yeah, I will explain one moment or why we came up with FlexRig. Yes, but so there is interoperability with others. So I said that the FlexRig can now do the agent and the rig side. Okay, so we have kind of interoperability both ways. So if you look at SRS RAN, so the GNB, the open source GNB from Software Radio Systems, for example, I think they have their own agent, but they initially used FlexRig. So there's a tutorial that you can use with FlexRig, and this works. There's also somebody who used NS3, and I don't know what they actually use as an agent. Maybe they also just FlexRig, but for example, can talk to NS3. We had a project with Keysight in one of the plug fests last year.
There's a good tutorial on that.
Yes, and basically they have their own agent, but this talked to FlexRig, and there was a kind of also a use case for some kind of QoS thing. So and then so in these cases, all FlexRig is the rig. There is also the other direction where we used the OpenAirInterface with the E2 agent from FlexRig, and we talk to the ORAN software community rig. So one of the big rigs, if you want, in open source is the one from the ORAN software community. And I will also maybe compare to that in a moment. Basically, we reproduced one of the demos using the OSC rig instead of using FlexRig. So last year, we had initially a demo, and I can show you the video. It's quite interesting what we did there, and you see the effect of the FlexRig. But basically, then later we reproduced the demo using the OSC rig. We still used OpenAirInterface in the RAN, and we wrote our own XApp. And then also we actually reused the service model, because the other thing with compatibility now is that you need compatibility on E2IP, but you also need it on the E2SM. So, and now the other question was what is.
Have you tried using micro-owners though? Micro-owners.
Me myself, no. So I will come back to this in a moment. Okay. The other question was, so what is the advantage of FlexRig? As you can see in the top, this is supposed to be ultra lean. What you saw basically is that it's a single executable. You run, it's quick, and so on. And this was kind of one of the design goals. Also partially, I mean, that wasn't the primary motivator, but when I started working on FlexRig at the end of my PhD 3 years ago, a bit more. And one of the problems that I had, I used the OSC rig, which already existed. And basically the OSC rig is a microservice architecture where you need to have Kubernetes, and it's big. It's also kind of slow to deploy, and it's at least complex to understand what goes where, because the different services, they talk to each other. And now as far as I know, so there is micro owners. This is also Kubernetes based with multiple services and so on. I never used it myself. So some people tried what they told me, and some people, I mean, also in Eurocom who work with OpenAirInterface, and they told me it's complicated. And it's complicated because you need to know about Kubernetes. So I was like a PhD student, and now I had like the pressure. It was basically like half a year before my defense. So before submitting my PhD, I was working FlexRig. I wanted to test with OSC rig, and I had no clue about Kubernetes. and then you need to understand Kubernetes, and then sometimes messages disappear in like in this messaging middleware, and you don't really know, and so on. So, and one of the distinguishing features, what we really said was that it's ultra lean, so it's efficient. This is a single executable, everything in the same repository, easy. At least that was the goal. Whether we achieved or not, and most then afterwards was somebody else who worked on that, because me actually I moved to Iran. So, but that was the goal. The other thing, there was also like this experimental use case. I don't know, you certainly know OpenFlow, which is the software-defined networking protocol to configure switches. And when I was as a PhD, I saw something where somebody made a kind of a recursive controller where there was a kind of an intermediate layer that would slice the switch that you can program, in the sense that, for example, it would only give you control for specific protocols, okay? And there was basically something on the southbound that was talking OpenFlow to the switch, and on the northbound it was also talking OpenFlow, and then there was a true controller, and they had like multiple controllers, and there was maybe one which was for the gaming network, another professional, and then you would isolate these things like and slice it, okay? So, and I tried, let's say like this, in the paper on FlexRig, for example, to make a recursive controller where you then also could recursively abstract and, for example, have slices, and then you have like two slices, which let's say one is 70 and 30, but it's again recursively exposed with the same protocol with E2, and on top there are two controllers, they both think they have 100%, and they then configure the slices and snap back. So, and I say this also now coming back. So what is the differentiator? So what we try to do is to have like libraries for, well, the rig, which you call the server library, and the agent library. And then there's this one use case where you have something in the middle, and basically southbound uses server library, northbound again agent, and so on. So this was one of the features where I thought that this would maybe be interesting also for other people to use. I think with the FlexRig as it exists now, you cannot easily reproduce it in that state, but at least from the paper there was this kind of thing, because as a PhD student I wanted to experiment a little bit in that direction and see what you can do. So, and if you use, for example, OSC rig, then you have this fat Kubernetes cluster, and I don't think you will deploy multiple and so on. So this will be more complex. So,
there's also something about this week.
So yes, so now let me just go briefly to the slides here to see, because this slide, they come back to that. So yes, and I mean, basically OSC rig and all the others, they are fed Kubernetes clusters, and actually that's kind of like put on paper in the specifications. I don't really understand why. So now, okay, that's something that I did. I mean, the idea was then to do multi-X, so multi-vendor. You can have different things. You have multi-red, so 4G, 5G. Multi-language is now Swig. So basically, there is an SDK for the X apps, which is written in C, but the Swig is a kind of a generator for interfaces, which takes the C header and which then generates for other programming languages. So the example that is actually done in FlexRig, and this works for sure. I didn't show this, but this could be, I mean, the XApps are bare bones, but they work, that you have a Python XApp. And via Swig, it then talks with the C API, and could also be made for Go or for Rust or whatever you want. Okay, so that's Swig. Yeah. So, and yeah, well, then you see here the basic communication. So basically between the run function and the near real-time rig, you have E2. In FlexRig, what they did a kind of an extension, a simplification of this E2, where it then talks what they call E42, or what is called in FlexRig E42, so that an XApp then sees what is there. I mean, which run functions and these kind of things. So here, this is a summary. This is a list of the service models that are supported. So basically, there are all these service models. So KPM, RC are the ORAN ones. And then you have these other ones, which is like the custom service models. And also the reason, by the way, why they are there is because before FlexRig in OpenAirInterface, on the whole, let's say OpenAir Cosmos, there was a controller called FlexRAN, which was mostly for 4G. And there you had kind of the correspondence to a service model where you had different statistics that were exported. So for example, PDCP and so on, so we implemented then on top of FlexRig in their own service model. There's also something for slicing. So this is one of the use cases. This is even in the instructions, how you can in 5G RAN with like a slicing implementation that is still kind of experimental and it's not yet merged to develop. But for example, you can slice the RAN resources and configure from an XApp. So there's now an overview of the different service models. I think that maybe goes too far unless you really want me to go into the details. But so the different things, and also for the RAN control service model, then there is actually a specified service model which is called cell configuration and control, I believe, CCC. Which basically gives you the same interface what you would also get on the O1 interface. If we go back here to the beginning, we said that there is this near real-time rig with the E2 interface, but on top you have the SMO, the service management orchestration, which has yet another O1 interface to talk, and the CCC gives you similar information than what O1 gives you. Okay. So by the way, also in this figure, you 100% see that there are many companies that all want to do their thing, and then all is.
There's no consensus.
No, well, there's maybe some. Well, I can't. My impression is that the E2 people don't like the O1 people, and they say that is bullshit, and the O1 people they say each other that's bullshit.
So now the compromise is let's have both.
Well, yeah. So. So, so FlexRig.
It's very bloated though. It looks bloated.
ORAN.
Yeah.
Yeah. No, that's super complex. That's what I was saying in the beginning. It's super complex. I think there are even people who say that some of the big vendors, they participate to make it more complex so that it will fail for sure.
Oh, okay.
I mean, at least
that
that's
sounds like.
I don't know whether that's really true. There's certainly things that work well. So, for example, there's the 7-to-2 frontal interface that they specify, which is also complex. But then you can like use different things and so on. They have also some specifications where they actually clarify F1, because in this F1 specification from the 3GPP, you can interpret a lot of things, and we implemented it first time. And then there was another DU that came that we wanted to interface in OpenAirInterface, and it didn't work at all. So then we went and we implemented what ORAN says on top, and then things work better. And so then you have of F1, but then you have a lot about infrastructure. Then you have E2, O1. You have a lot of things about security, because now you have this complexity. But now you have the open network where you cannot really trust the other entities. So you need to have the whole security aspects on top. So it's big. So FlexRig repository. And that's it. The one thing that I can show you now is another demo if you want, for the quality of experience, if you want. Otherwise, I can also just give you the video. You tell me what you want. If you say, okay, thanks, thank you, Robert, but have a nice day.
Then I understand. See how we actually deploy the XApp in the near real-time.
But this was what I showed you before, but basically it's just you start the so, CMake E2 build. So, no, that's not what I wanted. And I need to actually go up here. So basically, we deploy the near real-time rig. Okay, that's a single excitable. And now what we do is we start the GNB. The GNB will talk to the near real-time rig. Oh, wrong password.
Can you have one near real-time rig that communicates to, let's say, 2 or 3 GNBs?
Yes. And now on top of this, we deploy the XApp. So what was money something? So XApp KPM monitoring. This is also a single executable, which you start, and by default just talks to near real time on a specific.
So that's the UE and the agent, right?
So the agent is inside here.
Inside the GNB.
Inside the GNB.
Okay.
It talks to FlexRig. And the XApp is also part of FlexRig. And now you see the talks here, and then you have what we discussed before, the subscription request, which goes down here to the UE, and then and the run, and you also have the subscription request. And then basically periodically it's sending an indication, except that here's nothing to send because there's no EE, so it doesn't match. So it just prints, okay, cannot send anything. And then at the end, the accept terminates, so it makes the subscription delete. This was the thing I left out, but basically you can set up a subscription, you can also delete the subscription. So, and then you can connect UE and so on. So, but this whole deployment aspect and all the other rigs, for example, micro-owners, is that Kubernetes with some deployment things. We have some service that handles the X app and deploys the X app and so on. And the goal of FlexRig in some sense was to actually keep it simple because it's complicated enough.
It's like 3 commands per
Yes. So,
Can you maybe show us the video?
Yeah, well,
KIS demo.
so the demo is
Is that the one that you did with Keysight?
no, there's another one.
Okay, cool.
Okay, I also wanted to ask, since FlexRig doesn't include the non-real-time rig, how do we integrate machine learning within the
Yeah, this is by the way also another thing now. According to ORAN with FlexRig, not at all, because you don't have A1, so you cannot.
So
I
you
think there's a,
cannot.
well, but what I don't really understand about all of this is you have already the XApp, which runs separate from the near real-time rig. So you can write your XApp, which does the machine learning and which then sends the commands. At least for a proof of concept, this would be simpler.
It's only a timing requirement that's basically the difference.
Yeah, I mean, that's where they say now the non-real-time rig is non-real-time because it might take time, and then it sends down a policy and so on.
You're experimenting. You can
Yeah, I
talk
mean,
about
on the other hand, of course, there are like people who then write papers about the A1 interface and
Or if you can just keep it and go for the O1.
Because my research is basically based on that. Basically developing an ML-based radio resource allocation using an XM.
But you can write the XApp, which then decides and sends the command directly. I mean, you could, of course, use A1. Maybe it makes sense. I don't know, because then the idea is also you have one SMO which knows the entire network, and maybe you have 10 non-real-time rigs, near real-time rigs, sorry, which then manage the 1,000 base stations. But whether that's what you need for like a research proof of concept, so.
Yeah, no, I have your email. I'll contact you if.
So, let me just go briefly with a couple of slides to just state a little bit what we wanted to do or what we do in this demo, because also that is now complex because.
Love it.
The what?
No, it's like you're the machine. I just love you. Just
yeah, well, because it's. So I need to go here, and then I go to Oran, and then Athens. So this was something that we showed earlier this year, and then O1, E2 presentation, and then this is the same. This demo was actually E2 and O1 together. The O1 use case is just to get like configuration and then to restart. So I can also show you this, but that's basically it. Okay, that's relatively simple, and I will focus on the E2 aspect. The setup is the same that you also see there. Okay, just didn't prepare. If you would have told me, I could have also tried to read. But okay, and the idea is the following. So ignore here this A1 and so on is not implemented. We used an ONAP-based SMO. This exists, so you could probably also hack something. I don't know whether you really need A1, but if you want to use something, you can, for example, also make direct the connection to the XApp. So, but the idea is the following. The idea is that we have a split CU-DU base station, okay, and we have a UE in our system, and the idea is that it might be that I mean, we have an application which will be a game, so you can actually see, and the user wants to play this game, and now if there is some form of congestion, then the game will lag and not run smoothly anymore. So, and the idea is that via the X app on top of the near real-time rigs, or let's just say the rig, will optimize the network to make sure that the game runs smoothly, because that's the most important thing, right? You have congestion, but the game is very important. And now you have the thing is, I mean, the twist is a little bit that if you want to reconfigure something, this is on the CU level, but the congestion will rather see it on the DU level. Okay, at least we assume this now. And therefore, what we do is the DU, on the DU, we make the measurements and we see whether there is congestion in a very simplified fashion. And if we see that there's congestion, then we trigger an action on the C, which will reconfigure the network to make sure that the latency remains low. So that's the idea. That's the setup. That's the SMO. And basically, we have the XApp, which is deployed on top of near real-time rig, and it monitors something. And basically, it monitors on the DU, the UE performance via the KPM, and basically measures or gets information of how long packets wait in the RLC sublayer. And then on the CU, we can modify the run configuration by adding a new DRB and basically segregating the traffic of what congests and the game. Also, by the way, one caveat, so this is first of all, kind of artificial use case, because you might see this otherwise. This may be also not 100% realistic. The buffering would also actually happen in the CU, but in OAI it still happens on DU, so there are kind of some things. So I don't want to say that this would be really in in the real system, but this kind of shows what you might be able to do. And the choice of DU and CU is that you get these statistics from, or things from, two different points in the network, which you would not have at one, and then trigger some action. Okay, so just the small caveat. And basically what we say is if the packet queuing delay in the DU is larger than X, then we add a bearer, and if it's lower, then we release the bearer, and basically we use the KPM to get the measurements, and we release on the round control. So then here's also the overall exchange for message. So at some point we see, or there is some load, which will just be iPerf on the same user that is already in the system, but doesn't really matter. Then we see that no, there are many packets that wait for a very long time. So we deploy a second bearer with F1, all this kind of thing happens. So the background story is clear, right? So, and now there is a video here. The video, there are two videos. Actually, I will briefly show the one with the ping, and then because there I can take a little bit more time and show what's happening. So here, this is the O1 aspect. I will just go over that. What we had here now is what we also saw in the past. We have here the CU, here the DU, here is the near real-time rig, and here will be the XApp, and this is the phone that we also have here. So this is basically the same thing as yesterday. Now we start the DU. We see here the E2 setup request and response. So then this is O1, so let me skip that. So, and now what we do is we connect the phone. And in the beginning, so now at that point when I did this was, by the way, also the last day before flying away, and on exactly that day, the game that I wanted to play, which is some web server, was down, so I couldn't make the video. Okay, so there's another video we can actually see. But on the other hand, here is good to see because you see on the ping packets what really happens. So you see the overall thing. So basically, I wanted to play this, didn't work. Okay, so it loaded, but then nothing happened. So, but you see already now the system is unloaded, ping is low, everything is fine. And now the thing is, I do the iPerf, so it's also the same thing that I showed before. And now if I start the iPerf in downlink, and I just remind the XApp is not deployed yet, so nothing will happen. And basically here the round trip time will explode. Goes high, and we of course also force it a little bit by sending multiple TCP streams and so on, but overall the round trip time goes high, goes to 1 second, and the game later in the other video you will see won't work anymore. And now we just deploy the XApp, and the XApp will do one thing. It will measure on the DU how long packets wait. So here they wait super long. Okay, this is actually in microseconds. Okay, it's not no. So some measurement. And then what it does, it will deploy a second bearer. So because here I started it, you see that there's this rig control message, and we then receive this here, and we see a trigger new bearer, so it immediately deploys a second bearer. And you then see that basically afterwards the round trip time goes down, because now we have these two bearers. So basically what happens also here in the DU, we deploy the second bearer. Before we had this LCID 1, 2, and 4, which you have seen, and now we have an additional LCID 5 for the two DRBs, and basically the ping of the game goes through this LCID 5, which is preferred at the scheduler, and therefore is low latency, okay? So now latency is low. If we stop iPerf, then so now there we see it's like 100 millisecond or average waiting time, something like this. We stop here and then it's almost zero, so the bearer is released. Now we start again, it measures that it's high, it deploys a new bearer, and so on. Okay, so that's the basic principle. And now the other video, just to show for the fun of it, is to actually have this with the game now. So again, I start the near real-time rig. It's the same thing what I had before. I have the CU, I have the DU. Okay, so here we also see ng run gnb CU, and then we have ng run gnb DU, so the two registered. Then I connect the phone. I do the ping also in parallel, and I play this game, Slither.io. So this is kind of a snake-like game where you actually play online against other players. And so now it runs smooth as long as there's no traffic. XApp is not running, and now I will create traffic using iPerf, and now the the round trip time will explode, and also the game doesn't work anymore. Okay, so it doesn't. So that's the thing. And then I don't know. I think I really didn't do it on purpose, but you die if somebody tries to kill you. So and we don't want to die.
Nobody wants that.
Yeah, exactly. So we start the game once more, and now what happens is the game will remain smooth. More or less, also I have to say, because the whole system, of course, has an inherent waiting time. So we measure, we send every 100 millisecond. So if like all of the TCP packets come and they bloat, then of course for a short time you still have some kind of lag. So that's what you see there. Okay, but afterwards then it gets down again. So there you could now tune with, I mean, either you make it really fancy with AML and you predict when the TCP stream will come, or so you see there also, I mean, sometimes you see, sometimes not. So but you get the idea. Okay, that's basically it.
She basically gave the flex, the rig permission over the E2 interface to request another bed, which is then accepted.
Yes.
Okay.
And also, by the way, also one detail here. So we do this traffic segregation at the SDAP sublayer. But normally you might not even be able to look inside because maybe traffic is encrypted or I don't know what. Normally this segregation would happen actually in the UPF. I think that's also something that Stefan mentioned with QoS and so on. So you would do this there, and you cannot actually really request the creation of a new bearer. What you can do is you can request the mapping of quality of service flows onto bearer. So you see there are also a couple of shortcuts because we don't have the full implementation of the QoS stuff and so on. So that was to show what you can do with E2 and so on.
Thank you.
So,
Thank you
and
very much.
that's what you can kind of implement. Yes. I can also just a couple of things. I mean, maybe that's interesting for you. So, for example, before we had this FlexRun controller, what we implemented there in 4G times was I worked on this MOCN feature. So this basically connection of one UE to one genode or enode B to multiple core networks, and then you have like multiple PLMN that are advertised because at the time there were no slices, and then you can, for example, either add or remove core networks. We could then do similar things via E2. So maybe you reconfigure resource allocation, you could reconfigure with which PLMNs or which slices are announced. In theory, in E2, they specify mobility control. So we're currently implementing this, and this you will be able to do for sure, okay? So just send the control message and trigger the handover. And then, I mean, the other thing, by the way, with OpenAirInterface, it's nice to do something, but if you really want to go and do it kind of, let's say, algorithmic and show the gains, like a real network is always a little bit difficult to handle. But on the other hand, that's also one of the reasons why this needs to be simple in the Flex rig, because as I said, we did the same demo with the OSC rig, and sometimes it loses messages or so, and then you bring up the whole thing. This takes 3 minutes, and you spend like 1 hour to do the 1 minute demo video just to get a proper take and so on. And of course, if you tune and if you know what you do and so on, then you get it stable. And I don't want to say that it cannot work, but for a small proof of concept for a PhD student or something like this, for me it was a nightmare. Let's say like this, okay? That's why I have gray hair now. Because of the OSC rig.
Thank you.
Yeah, no, this was informative.
Yeah.
Thank you.
So yes, and if you have a question, I mean, I can send you the slide. Also, the demo video is already online. So